Hey everybody. Well, we're getting ready to move into galaxy season. I did a recent video where I identified two targets, NGC 3359 followed by NGC 5906, to begin my version of galaxy season. I'm going to be using APT, Astrophotography Tool. In this case, it's version 3.82, and I'm just going to walk through the software as I make the changes necessary to accommodate all the new equipment or the different equipment that I have for galaxy season, and also set up a sequence, an imaging sequence in the imaging plan area for this software. Now I'm inside, but I've got all the equipment hooked up electronically. So this is the Pegasus Astro Ultimate Power Box version 2. I have it on. I have the environmental sensor plugged in. It's reading the indoor temperature, humidity, and dew point inside. I have the ASI 1600 main imaging camera. I have the focuser. In this case, it's the Celestron USB focuser plugged in. I've got data turned on to the focuser, which is a USB 2 controlled via the USB 2. I've got the mount also controlled via USB 2, and the ASI 1600, which is controlled through USB 3, but it has a hub on board that handles the focus wheel and the guide camera. So in a way, this setup is exactly identical to what it is when I'm using my ED102 and the Pegasus Astro Focus Cube 2. Nothing here is changed at all. I will have a dew strap plugged into the first dew heater, dew band A input, and I will be using the focuser is different, but it's still getting power using the 12-volt supply, same camera, and of course the data. The USB connections are the same for both. So from this perspective, this stays identical to what it was before. Now let's go over to PhD2 guiding. So I've started PhD2 guiding here, and going into connect up, I'm going to be connecting to a different guide camera, and of course it's attached to a different imaging setup, so a lot of things have changed. Now I've already have set up an imaging profile for this. So, for example, there are different combinations of guide camera and telescope that I have been using in the past. In my case, it's the ASI 174 Mini combined with the C9.25. I have another setup here when I'm using the focal reducer with the C9.25, but in this case I will not have the focal reducer installed, and I'll just be using the ASI 174 Mini with the C9.25. Now, if I go into here, it's an ASI camera. I can select and confirm that, in fact, yes, it's going to default to the ASI 174 and connect that up. Likewise, the mount is the same as the Celestron telescope driver. I can connect that, and it takes a minute. And so it comes up and says it's connected. Now, over here, there are a couple of things that I can change. For example, you need to verify, and this is what you do when setting up a profile. Guiding is set through a focal length of 2,220. This is the focal length of my nominally 2,350 millimeter focal length for the C9.25. However, in doing an image solution of a picture I took with the DSLR, it was telling me that the effective focal length is actually much closer to 2,220 millimeters. So that's what I'm typing in here, not the theoretical value, but the one that seems to fit best with the images that I'm actually taking. And then you can go in here to come up with an estimate given that focal length, given the pixel size of the ASI 174. It will come up with and recalculate a calibration step size of 350 milliseconds, and so that's what you do there. Now we can go over to Astrophotography Tool and bring it up.
Camera connected, telescope connected, focuser connected, filter wheel connected.
All right, so here's the basic input, the initial window we have in Astrophotography Tool. As you could hear, and one of the things I do like about Astrophotography Tool is the verbal feedback you get when it's executing a command or has accomplished some task that's been given. I do like that about Astrophotography Tool. Down in here, it doesn't look like there's anything we need to change. I'm using the same imaging camera, so right now the gain is set to 139. That's something that'll change on a case-by-case basis. Let's go into the gear tab. You'll notice that the wheel is the same filter wheel I've been using, so that doesn't change. Now, the focuser in this case is the Celestron USB focuser setup. So this is the USB focuser driver that I'm using here, and you'll have to take note of what COM port it's on because you may have to enter that in at a later date to make sure things are connected right. But this is one difference that I have to make. I'm using a different focuser. It's not the Pegasus Astro Focus Cube 2. Instead, it's the Celestron USB focuser that I'm using here. And one of the things that I'm going to have to learn is what is a good step size for this. I don't know this yet. I haven't been out imaging with it, but it does work. For instance, if I go forward 20 steps, you'll see the focuser position advance 20 steps. If I come back, it goes back 20 steps, and you can't hear it, but I can hear the focus motor turning just over to my left here. The scope is connected. It's in track mode, so everything's working there. It connected to the scope. Of course, the mount is the same as before, so nothing really changes there. If we go into the tools, now there are a number of APT settings here that I'm eventually going to have to change. For example, the scope and the focuser. One of the challenges I'm going to have is that the temperature source, I don't have, there is no, at present, there is no ASCOM environmental sensor. And if you go back to, it would be very nice, but I don't believe APT allows this at the moment. But if I go back to the Pegasus Astro Ultimate Power Box, it has an environmental sensor, so it has temperature. And it would be nice if I could get this temperature reading to be incorporated into APT, but for now I don't believe it's possible. Maybe in the next version it will be. So going back into settings, eventually I'm going to put in new offsets. These are the offsets from my Pegasus Astro Focus Cube 2, and so these will not be applicable for the Celestron Focuser. The step sizes won't be. So I'm going to save those off as 0. All right, so now in tools, you notice we have focal length. Now this did say 700 millimeters for my ED102. Now it's going to be 2220 millimeters for this particular telescope. The camera pixel size the same camera, so that's okay. Moving on, I think let's go into the image plan. And let's come up with an image plan for my target set. In a previous video, I came up with these as my two targets. There's NGC 3359 that will pick up around 8 p.m. and carry it forward until 12 a.m. And these are the RA and the deck values I got by moving the target around and trying to get this guide star into view. Likewise with NGC 5906, we'll pick that up at roughly 12 a.m. and go to 5 a.m. with that target. And these are the RA and deck values I found by maneuvering these two guide stars into view, and so I'm slightly off from the center of the galaxy here. But these are the target values that we want to use in our image plan. Okay, so the first thing we need to do is enter in the actual target coordinates, the deck and RA and deck values for the coordinates. So let's go back to the Gear tab, go into Objects. Now, I have created a list of custom objects. Sometime back I did a video of finding all of the DSOs that I can see from my backyard that are worth taking a picture of. And so I created that list, converted it into a format that I could load into APT's custom target list, and that's what you see here. So I've got a ton of these targets listed in here with the original actual official targets, target locations based on whatever catalog I pulled it from. So what we want to do is find NGC 3359 and check its coordinates for this particular imaging session. So there's NGC 3359. Let's edit that. And we're going to have an RA of 10 and then 46 and then 54. So not much of a change, frankly, or 49. Frankly, that's not much of a difference, and my scope's not going to be able to be more accurate than that. On the deck, we have a 63, 14, and 12. So I'm going to change that to 14 and change this to 12. Camera angle is not important. I went ahead and put it at minus 25. Magnitude, the size of the object for this particular target is 4.6 arc minutes by 1.9 arc minutes. And then we'll save that. Don't forget to save it when you do this because it will forget your settings if you don't if you don't save it. And now let's scroll down to NGC 56 or 5906. Here it is. Let's edit that. So NGC 5906, and here we have a 15 hours, 15 minutes, and 42 seconds. Once again, not much of a change. And for deck, I have 56 and 19 and 56 seconds, arc seconds. And in that case, the target is it's more needle-like, but I'm just drawing a circle at 8.5 arc minutes, and we'll save that information. Okay, so now we have the target coordinates, our aim points that are consistent with our image session planning with Stellarium. That's all we need to do in terms of setting the coordinates. Okay, so let's set up an imaging plan for our first target. Now we'll go into the edit button here. We'll select the type of plan that we're talking about, which is a light plan. Let's go ahead and change the name of this, and then we'll save it off. NGC 3359. And now we'll start working with this as a brand new light plan. Now let's also think about how we're going to be approaching this target. This is the first target of the night, so I will already have focused the scope. I will have slewed to the target and done a plate solve to get to the preferred ideal target location. I will have already initiated guiding, found a guide star, started PhD2, and started guiding. So when I execute this plan, the only thing I really wanted to do is just start taking pictures. Now, we want to take pictures for about 4 hours. We expect to start around 8 p.m. We want to end around 12 a.m. There's no ability currently within APT to say, drop what you're doing at 12 a.m. and slew to the second target in the sequence. That means the burden is on us to pick a number of exposures and exposure times that add up to 4 hours. And so that's something we want to have in the back of our mind. The first thing we want to do, though, is to make sure that we have the camera gain set for, I'm going to start off with the wide band filters. So I'm going to use a gain of 100, and you'll notice over here in the where we enter in the various values or parameters, the parameters for plan, there is no column here for gain. So the first thing I want to do is to execute a script in which we set the gain to 100. I'm going to say we have an exposure of 0 seconds. I'll put in 1x1 binning, but frankly, obviously it doesn't matter. We're not taking a picture. I'll put in a pause of 5 seconds just because I like to do that. And we'll put in a count of 1. And we're going to go ahead and change the filter to luminance. And now let's go ahead, come down here and put in a script. And there's a number of script items we can choose from, but it turns out that CCD gain is the first one. So I'm going to select that, and I'm going to type in a gain of 100. And then I'm going to add this item as a new item. Now, so this is doing really nothing more than it changes the filter to what I'm first going to be doing exposures with, imaging with. It also, you'll see a little apostrophe up here that tells us there's a script associated with it. We have a gain we're setting the CT gain to 100, so that ensures that we won't screw up on the gain because there's no other place to enter it. All right, so that's the first thing we're going to do. The next thing I'm going to do is do 50 exposures, say, of the luminance. I'm going to do a bin of 1x1, a pause of 5, a count of, I'm going to do an exposure of 100 seconds and a count of 50 of them for the luminance filter. And I'm going to not have a script, and I'm going to add that as new. Now you'll notice that there is no apostrophe now in front of the second item in the list here because we don't have a script associated with it. Now I'm going to change the filter to red, and I'm going to change the number of exposures to 25, and I'm going to add that as new. I'm going to keep 25, change it to green, and update that as new. Change that to blue, add as new. And now we have approximately 125 exposures. That gives me a little bit left over for some HA, so let's go ahead and switch to HA. However, I got to be careful here because I want to switch the gain as well. I'm going to do a 0-second exposure. I'm going to do a count of 1. I'm going to do a pause of 5, but I'm going to go back and set the gain now to 139 as I switch to the gain I typically use for my narrowband filters. And we will add that as a new item. So you'll notice we've switched the filter to HA. We have another apostrophe. Let's go down here and check, and sure enough, we are changing the gain to 139. And now I'm going to, in this case, I'm going to say no change. I'm going to have an exposure of 200 seconds. And I'm going to do a count of, let's say, 15. And we will add that as new. Now, up here, for example, I could have just, because I set the luminance filter on that first script item, I could have done this and said no change, update current, and now the filter doesn't change. Now, the logic of the filter wheel is probably not going to change anything anyway, but you could certainly do this. It's equivalent because I will have already had set the filter to luminance. So now we go through luminance, red, green, blue, and then we switch the filter to hydrogen alpha, switch the camera gain to 139, and we set the take 15 exposures with the hydrogen alpha. Now let's go to the calculator and figure out how much time this actually is. This is another thing that it would be nice if there were a continuous readout as to what kind of total imaging time this is, so that you could, as you're laying out your 4.5 hours. Okay, so that we are 30 minutes long on time. So what I need to do is cut out about 30 minutes. And if I came in here, took out, let me go down to 20, update current, change this to a 20, update current, change this to 20, update current. That should be just about right. I have 4.06 hours. Okay, that's good enough. Okay, so at this stage we have 4.06 hours of imaging with NGC 3359. Let's go ahead and say OK to that plan. And now what we want to do is to create an imaging plan for NGC 5906. We're going to start off with a new imaging plan, add a new light frame, and we're going to call it NGC 5906. But I'm going to assume that I want it to slew to the target and begin guiding on its own. So the first thing we're going to do is put in a script and have the whatever guiding is going on to stop. So let's go down here, go down to guide control, tell it to stop guiding, and we will have zero exposure, 1 by 1. Zero exposure again tells it not to do anything. We're going to switch to the luminance filter. It will have been on the HA filter, so we'll go ahead and switch to the luminance filter. I'll add that as a new item, and it will stop the guiding. The next thing we're going to do is go to another script command and have it go to the NGC 5906. That'll be a go-to ++ command. The exposure seconds will be something on the order of 3 seconds. I want to do a solving on the near. I don't plan to be that far apart, far away from it, because it will have been synchronized already to NGC 3359, so we should be pretty accurate. Go to the object list, go to the custom file, there's NGC 5906, and we will say OK. It copies in the coordinates. That's the aim points that we entered in a moment ago, and that gets us to the target. Now, one thing I want to be sure and do here is tell the script to wait until it's finished. In other words, it's one thing to send the command to do the go-to ++ move. It's another thing for the go-to ++ move to have time to move the scope, do the plate solving, make adjustments, and so on. And so we want to wait for everything to end before we go on to the next step here. And I'm going to add that as new, except I'm going to take off the filter change and add it as new there. So we're not changing the filter. We're still on luminance. We will now start guiding. There's guide control. We will start. And so now what APT will do is to identify a a new guide, let PhD2 identify a guide star and start guiding with the parameters that's already been entered in PhD2. And once again, I'm going to wait and let this in, but I think I'm also going to crank this up to a 30-second delay because I want it to have time to settle out a little bit before it starts doing anything. And so we'll add that as new. So we started here, we stopped the guiding, we moved to the new target, and we started guiding. All right. Now we can start the imaging process, but because we were in imaging with HA in the last plan, we're going to be imaging back with the broadband filters now. So I want to do yet another script and tell it to change the CCD gain to 100. And you could wait to end. It doesn't take any time to switch the gain. It certainly doesn't hurt to leave it there, but I don't need a 3-second pause for that. So I'm going to change that back to a 5-second pause and add that as new. Now everything is set up for our imaging. We have a good 5 hours of time on this target, so we can keep that in mind as we're laying out the images. And for the purposes here, I'm going to say we're going to have an exposure of 100 seconds, a pause of 5 seconds, no change here because I'm going to image first with luminance, a count of 50, and we'll add that as new. We will then change this down to 25 and change this to red, add that as new, and we will change the filter to green, add as new, change the filter to blue, add as new. And now we will bring in whoops, now you see I made a mistake there. I was putting in, we changed the gain here. Now I say it's a mistake. We could change the gain every time we do this, but it's kind of silly. So I'm going to delete the script command and update the current. You can see the little apostrophe went away. I'm going to come in here, delete, and update current, and delete, update current. And now I'm going to add a new one, in which case we're going to be back to 0 exposures. 5-second pause is fine, count of 1, switch to the HA filter, go to the script command. Now we're going to switch the gain to 139. And I'm going to add that as new. And now the only thing it's doing is switching the filter to HA and changing the gain. And for the next one, I'm going to take out the switch to gain. I'm going to leave the filter as is. I'm going to change the exposures to 200 seconds now and do a count of about 15. And if you remember from the last NGC 3359 when we calculated the amount of time it would take, it was about 4.5 hours or so. So this combined with a little bit of overshoot on the last one means we'll be done before this the mount reaches the meridian. This is supposed to reach the meridian around 5 a.m. and so we should be done by then. I can overshoot the meridian by good grief, maybe an hour before I really get concerned. So this gives us plenty of margin to overshoot the meridian by a little bit, if in fact we do that. And we will add that as a new item. So that gives us all of the images for this particular plan. We have 200 and at 15, 200 seconds at 15, and so that becomes our imaging plan for NGC 5906. I want to create a shutdown script. It'll be a light plan. We'll change the filter to luminance. We'll have 0 exposure, a count of 1. We will have guide control stop. That's a good fortuitous combination. So we will stop guiding. The next thing we will do is issue a command to warm the CCD, and I'll just use the parameters that are in the warming aid. So I'll use that, warm the CCD. That's okay. No need to change the filter again, so I'll leave that out, and we'll add that as new. And then we will park the scope. So another script here to park. And no filter change once again. We'll go ahead and, for whatever it's worth, click wait to end. And we will add that on as a new item. So we start here, we stop any guiding that's going on, we set the camera to start warming, and then we move the scope to its park position. And in this case, I'm going to call this shutdown. Let's go back to the script we first created, the NGC 3359. All right, so this is the script we created for the NGC 3359. Let's add on the script go to the next target, the NGC 5906. And in this case, I want to have a commands of next plan. And we need to select the imaging plan. It will be NGC 5906. We'll say OK. And we can go ahead and have it switch to a luminance filter if we want. That's no problem. It's going to NGC 5906 plan is going to do that for us. And we will add that as new. Now it entered it up here because that's where the selection was. So let's just move it down. Okay. So look at this script. First thing we do is set the gain to 100. Then we do imaging with the luminance filter, the red, the green, the blue. We switch the gain to 139 and switch the filter to hydrogen alpha. We take some pictures with the hydrogen alpha filter. And by the way, we don't need a script here, so we can take that out and update current. It's always a good idea to go back through your scripts for the reasons you just saw. You can leave some stuff that you might as well fix while you're here. So now we're taking the pictures with the 200-second exposures, with a number of 15 pictures with the HA filter, and then executes the guide plan 5906, and we say OK. Now let's go to the 5906 to make sure the flow is correct. We'll edit it. Told the NGC 3359 plan to execute this plan. The first thing this plan does is stop the guiding, okay, because it was in guide mode. It will use the go-to ++ command to plate solve onto its intended target for 5906, NGC 5906. It will tell the guiding to start back up again and wait 30 seconds for guiding to kind of settle down a bit. It will change the gain to 100. All of this is with the luminance filter. And here, once again, we can take out the change the gain to 100 script, update current. So we're changing the gain to 100 here. And now we can come down here. We're taking pictures with the luminance filter. And then with the red and the green and the blue, we switch to the HA filter and switch the gain to 139. And now we take pictures with the HA filter. And now let's bring in the shutdown plan. So that's the next plan. Say OK. And we need to find shutdown. And so that executes the shutdown plan. We don't need to be taking any exposures. Don't need to pause. There can just be one. And we can go ahead and switch to the luminance filter for the next day's imaging and add that as new. All right, so let's walk through that again. Tell guiding to stop. We go to ++ to the NGC 5906. We tell guiding to start back up. We set the gain to 100. We now start taking images with the luminance filter. 100 of those are 50 pictures at 100 seconds, and then the red, the green, and the blue. We switch the gain to 139 and the filter to HA. We take 15 pictures with the HA filter and a 200-second exposure. And then after it's done, it's getting close to the meridian, we tell it to execute the plan to shut down. So there is a complete imaging sequence where we start with our NGC 3359, and then that sends us to the NGC 5906, and then that sends us back to park the scope. Now, just to make sure you know what park is, you should place your telescope in the position that you consider to be the parked position. For me, OTA is up, counterweights are down, looking to the north. Now notice up here the little bubble that comes up. It says press the shift key and the left mouse button, and that will set that park position. There's the process of setting up Astrophotography Tool for galaxy season for me and my equipment, and for the setting a imaging plan for the first two targets of the season. Okay guys, well I guess that does it for now. I'll check in with you when we have some clear skies. See ya.